Another 1 minute, we'll wait, then we'll start. If other class has not stopped, then you can send me one SMS. Anybody want? I thought that the Zoom is not working, or sometimes it is happened. No? That's the reason. Okay, we'll start. Yes. So last class, anybody has any doubt? Quickly ask. No.
No, sir.
No, fine. Thank you. So last class we have simply discussed that how a user actually interact with the OS with the help of this API. Then today's class will think about how this interaction between these two is happening. Okay, because this is a gap. Why it is a gap? As I pointed out, up to this, all these things are done at the user level. But the moment you come to the OS, then it is become a kernel level, because the kernel is actually the part of the core of the operating system, and that kernel itself is a software, and this OS becomes a software, and this APIs and system programming are also software. Then how these two things get distinguishing between this? As I have pointed out, if there is a printf function is an API which is accessed by the user, then this printf is not capable to directly interact with the hardware to do this. Rather, what he has to do, he has to take the help of the OS. And what the OS provides? The OS provides the functionalities through which he can able to write it. So, and also I discussed there may be a different kind of application program interfaces, but all these interfaces try to use the same write system call when they are going to write. Like I'll tell you, you studied about a puts, you studied about printf. In case of puts, when you are writing puts, if any question regarding your programming, you can ask when I'm telling about puts or something. A puts is a function which is able to write a string to the monitor, and your printer is also a function which is able to write by a percentage s to a monitor. Then how you can distinguishing these two things? These two things are basically the APIs, but both the APIs are going to use the same system called as write. Okay, what is the then how this printf can able to call this write system call? This is the first part of today's lecture, because write is also a function. It is also written in C language. The printf is also a function and written in the C language. If you can able to call this printf, then you can also call this write. Yes or no? If I can call this printf through which I can do it, I can also call this write, but I cannot able to call this write. The reason, there is a restriction is in between the user mode and kernel mode. So what is this restrictions are? Basically, the kernel mode says that yes. Now, if you can go to the first point, the code written in the kernel mode is unrestrictedly access the memories and hardware. Means the code present in the kernel mode can unrestrictedly access the memory or the hardware. Whereas your user mode cannot directly access any kind of hardware or any kind of memory. Now you can say, sir, when you are writing a program, always I am using a memory, and you are saying it is not using. What's the meaning behind this? Just look into it. One small program I'm writing, and you can tell me what happens. Yes, suppose I'm writing a int a equal to 5 and int star b is equal to a. And if you can wants to display this a, or forget about this also, if I want to display printf this percentage p with ampersand a, we know that a has a memory. This memory is, let's take 200, and this 200 is the address of this memory, and we are happily saying that this is the memory address. Plus, please remember, the 200 whatever it is showing, this is not a actual address, rather it is becoming a virtual address. Yes, how you can identify? You can identify by looking into it. You can write, there is a open two terminals, and you run this ./a.out, and you run here also ./a.out, and you run this program. Whatever the address it will show, the same address may be shown it here. The reason is that the moment you execute a program, it is temporarily created a virtual memory, not the actual memory. Means he feels like it is a memory, but actually that does not exist. Like I can say, I'll purchase a 10 acres of land. I can directly purchase, go there, and I think that this is my land. In other way, I can say, in a piece of paper, I draw this land, the shape of this land, and write down the number, everything present, I draw it, and I can show to somebody that this is my land. By looking into this piece of paper, one can identify clearly that where this land is located, what is the size of the land, what are the things are present, everything you can see from the sketch. But actually that is not the land. The land exists in some places. In the same manner, your RAM, which is actual memory you think, that is present in the RAM as a hardware. But the address, whatever it is giving, he is temporarily saying, when I'm creating a, my program, if it is start at a 0, then the a is at a 200. For this program also, he is thinking it is my memory. His memory is also started at a 0. And his program A may be present at 200. Do you think that both the program have the same memory? Is it possible? It is not possible. So what does it mean? You are not accessing the real memory, rather you are accessing some kind of a dummy or the virtual memory, which is not actually the physical memory it is. So that's the reason they are saying, in case of a kernel mode, you are eligible to access this memory and hardware. Whereas in case of your user mode, you are not able to access. Yes. And in the kernel mode, another point, in this kernel mode, you can execute basically the CPU instruction. Execute CPU instructions. But in the user mode, you cannot execute the CPU instruction. When the CPU is going to be execute some basic instruction, it has to be come to the kernel mode, and in the kernel mode it is going to do it. Now you tell me, if actual instruction is executed in the kernel mode, let's take the kernel crashes. Do you think that your CPU will be run or CPU will not run?
Stopping.
Not run means you can say directly it will going to be halt situation. But in case of user mode, even if this program crashes, it is not affecting in my memory, because the memory is not directly accessible to him. He is saying I am crashing means I am deleting some part of this memory, which is a dummy memory. I teared my paper. It doesn't mean that the land gets destroyed. The land is still there. So that's the basic difference between a kernel mode and user mode. In case of kernel mode, it is more restricted. In case of user mode, it is in case of user mode, it is restricted, whereas in case of kernel mode, there is no restriction of accessing any kind of hardware. Okay, and in this kernel, please tell me.
Sir, who is providing me the virtual memory?
Very nice. Who is providing with the virtual memory? So the moment you create a process, we'll tell what is a process. Means for now, what is a process? The moment you write down ./a.out, a operating system will be give you a dummy page kind of things. You think that he will provide you a dummy page where it is written that your variables will be stored from 10 to 20. Your code will be stored from 100 to 200. He's just telling like this. But actual code is not currently present in your RAM. Whenever the code is required, it is bringing it. Why? In data structure class, or sometimes I might have told, do you think that how much memory this virtual memory will be allocated to a process? When a process is created, have you ever think about how much memory is going to be allocated? It is allocating a 4 GB memory. If I am allocating a 4 GB memory to this process and this process, how many processes are currently running? Thousands. Do you have a 4,000 RAM space? 4,000 GB RAM space? You have hardly 2 GB RAM space. Means now you can say that whatever the memory the CPU is operating system is giving to me at the very beginning as a virtual, that is not actually present. Then how it is working? So whatever the data I require to currently executed, for this data he is providing me the actual memory. Then he is bringing this data, execute, and again return back to this space. Like you can say, I have only one small space, one small kitchen, but there are 3 householders are present here. Then what will happen? The 3 householder cannot enter into here and at a time execute. Rather, he wants a breakfast. He goes inside this, prepare the breakfast, comes out. Another person wants a lunch. The same memory it is utilized. But I am telling to him that I have a 4 GB memory, but actually you don't have a 4 GB memory. Okay, so that's why the operating system is providing this kind of memory, even if it looks like a virtual. Okay. Ask.
Sir, if we are running this program in the pseudo privilege, then also this will happen.
Yes, even if it is what the pseudo privilege says that we'll consider. Even if you are writing a pseudo privilege, he is telling you are eligible to access the programs which is not usually belongs to your user account. Yes or no?
Yes, sir.
User account. But he will never say that you can able to access a hardware directly. For accessing the hardware, anyhow, you have to go through this operating system, provided your system consists of an operating system. Because last class I told, if you can see in the back side of the bus that LED is blinking, that is also a system. But that system does not have a OS itself. Means your API is including the OS directly, which is capable to access the hardware. If my OS says that you are capable to access the hardware, then I have to do it. But if you will give like this, then the OS cannot manage the multiple users with thousands of programs. Some restriction is required. Okay,
Okay.
understood this?
Okay, sir.
Now, this is
Yes,
the
sir.
difference between the user.
Sir.
Oli.
Sir, in this example you have given, sir, the paper is user mode and the land is kernel mode.
Kernel
right?
mode. Yes, correct. This is I'm saying this is a virtual memory, not a user mode. Virtual memory which is used in the user mode. Because this paper is a land now. By seeing your sketch, you feel that it's a land. Land is not a program now. The land is basically a memory. And this is not at all exist. This is just sketch on the top of the paper. And this memory, I feel that I have this much memory, but actually I don't have this much memory. The memory is present in the RAM whenever necessary, the operating system is providing to us. Okay? Little understood? Fine. Next.
Sir, but this also requires memory.
One by one.
Sir, but this virtual memory also requires the storage, na? So where it is stored?
Very nice. So initially, when the operating system brings this virtual memory, initially your virtual memory, you can think like it is a paper. Paper is stored in the secondary devices. Means your hard disk source. Why it is a hard disk? Because when you create an executable file, in the executable file itself, all the sketches will be there. When you create a.exe or in a Linux platform, you are creating a.out. The a.out is a program where all the sketches of this memory will be present there. And your a.out is present in the RAM or present in the hard disk? Tell me quick.
In the
Hard disk.
Means initially it will be present in the hard disk. And whenever required, he will give me a memory in the RAM. I'll bring that part to the memory and execute it.
Sir,
Okay.
like that paging in the hard disk.
Very nice. That is paging.
Okay, sir.
Okay, fine. So that is one point. And that's the next point I told. Now, when the puts and gets has to be access this write, the write is also a function which is running in the kernel mode. But puts and writes are using in the user mode. But if I can able to access this puts and write, he is saying you cannot access this write. You can only access the printf and the puts, but you cannot access this writes. But my write is actually interact with my hardware. Then how I can able to access this writes is one. This write one has to be done in a certain manner. What is this manner? If it is my API, the moment this API is called inside your program, it generates a trap. The trap is basically called as a software interrupt.
So can you please repeat?
You know what I'm saying? When this user one is try to call this printf. The printf is basically API, and this printf, I told that it is calling a write function call. I told that every printf, if you can look into the printf, it is indirectly called some kind of function called as a write. But this write is not belongs to the user mode. This write is belongs to the kernel mode. Now you can say, if a F1 is calling F2, are you eligible to call F2 or not?
Yes.
If you can call F1 and F1 is called this F2, can you directly call your F2 inside your main or not?
Yes, sir.
Yes, sir.
Then
Depends.
if it is possible, then I can directly call the write. Please, based on the argument, you have to understand the argument. Very crucial points. This is. I told that in your C program, you have written a printf. Everybody agreed?
Yes, sir.
Printf is a function. The function has designed by a person who has made the C. And that function, we are saying it is an API. And you can able to see this function also. Suppose I can able to open this printf function. And I told that the printf function cannot access the hardware like monitor. The printf has to be take the help of a write function. But that write function is provided by the operating system. If write is a function, printf is a function, both are written in the C, then printf can call a write function inside its code. if printf is calls a write function, if I am able to call the printf, why I am not able to call the write? I can also eligible to call the write or not. That is my point. Are you agree or not?
Yes, sir.
Yes. If you can able to call the write, but write is in kernel mode. If you can able to call the write which is present in the kernel mode, then whatever the theory you have studied, that it is a restricted mode, a user cannot directly access, but I am able to directly access it, which is violating the protection provided by the operating system. But what I want to use the write, but I cannot call the write. How is it possible? I want to use the write through printf, but I cannot directly call the write. Even if I can call the write, it is not directly a function call, it will be something else. Then how it is happening, that I'm going to do it. And that is basically called as calling a system call. Calling a system call. How is it possible? Yes. So what is doing? The moment this printf calls this write, yes, this write has a number. Okay, let's take it is 43. A number has assigned by the operating system to this write system call. He has just called it. The moment it calls, since it is a system call, it will not directly call because the write is not available to him. What it does, it basically call a interrupt, and that interrupt is called as a trap. There are two kinds of interrupt. Sometimes it is called as an interrupt, and sometimes it is called a trap. The trap is called as a software interrupt. Software interrupt. I'll tell you what is software. And interrupt is a hardware interrupt. Then let's, what is the interrupt?
कॉल करता है, मतलब आप बोल रहे हैं राइट फंक्शन कॉल करता है ट्रैप को.
हाँ, write function, when you call it, no, when you, the moment you call the write function, the write is not called, rather a trap is called. Yes. And what is this interrupt basically? For this moment, what is an interrupt? वो हमें तो आप पढ़ोगे. The interrupt means, suppose I press on the keyboard and your mouse.
Priority change हो जाता है ना.
Priority अलग चीज है. मैं बस बोल रहा हूँ what is an interrupt? How it can feel like an interrupt? Okay. Suppose a program is running. Yes. The moment you move the mouse cursor will be moved there or not? It's
yes,
shown in the screen or not? But the mouse is an hardware, and a mouse cursor is a software or a hardware? Software. And previously one program is running. Now the moment you move this mouse, a cursor program is running. Now what happens? The currently existing running program is going to be interrupted by mouse movement or not? Correct or not?
Yes, sir.
Yes. Means the moment I move this mouse, some program is going to be run whose work is to display the mouse pointer at a different location of the screen. Means it is generating one interrupt. Then who is generating? Mouse. Mouse is a software or this? It is a hardware. That's why it is called as a hardware interrupt. Now we think about this. When the moment you call this write, I told that it will do something. Who is calling this interrupt? A write. Is the write is a hardware or a software? A program is running. Means it is a software. So this is called as a software interrupt. If a software can interrupt another person, then it is called as a software interrupt. If a hardware is going to interrupt another person, then a hardware interrupt comes into picture. Okay, that is the first point. Detail will be later. Then once this trap will be generated.
हार्डवेयर इंटरप्ट के बारे में फिर से बताइएगा. हार्डवेयर इंटरप्ट के बारे में फिर से एक बार बताइए.
यस, हार्डवेयर इंटरप्ट आपका क्या है? सपोज जैसे बोला कि आप अभी कीबोर्ड में प्रेस कर रहे हो. कीबोर्ड आप फिजिकली प्रेस कर रहे हो या सटल वे से कीबोर्ड प्रेस हो जा रहा है? Physically means you are physically contacting one hardware or doing something on the top of the hardware or not? And by doing something on the top of the hardware, some software is running in the background to display your mouse cursor or not. Because mouse cursor is just a graphic figure which is moving from different coordinate of the monitor. Correct or not? Am I correct or not?
Yes, sir.
Yes. Means it is a software. If it is a software, if it is become a software, then that software will be interrupting my existing software. Suppose एक पीछे कुछ चल रहा था, तुरंत में माउस मूवमेंट कर दिया, पीछे का चीज बंद होके माउस मूवमेंट वाला दिखा दिया. मतलब somebody is interrupting somebody else. And who is interrupting? My mouse is interrupting. Mouse is a hardware. That's why it is a hardware interrupt. But in this scenario, whatever I have drawn here, now I am running a printf. Printf is a program. And this program is saying I am generating an interrupt. Is it a hardware interrupt or software interrupt? Software interrupt. Got it? Yes? So it will be generate one trap. The moment you get this trap, now concentrate here. The moment you get this trap, there are different kinds of interrupt. Why there is a different kinds of interrupt? Mouse movement के लिए एक interrupt होगा. Keyboard movement के लिए, keyboard press के लिए और एक movement होगा. For the touch screen, there will be another interrupt, because there are a different kind of hardwares are present or softwares are available in your computer. For every hardware, a different functionality has to be run for this interrupt. That's why there are many interrupts, and for each interrupt, there must be a separate program is going to run or not. Step by step.
Yes, sir.
Yes, and that program is called as a interrupt service routine. Okay, and this interrupt service routine is nothing but a, you think it is a I1 function, I2 function, like this. These are the function, and this I1 function is for, let's take keyboard interrupt, and this I2 function is the, let's take it is a mouse interrupt. Yes, means the moment you move the mouse, this function will be called. But how this function will be called automatically? For understanding this which function, he is maintaining a one more table called as an interrupt vector table.
Sir, it is a collection of functions.
It is a collection, yes, vector table. And what this interrupt vector table stores? It stores what? 1 means I1, 3 means I5, 7 means I9, like this. What does it mean? For every interrupt service routine program, there is one ID is assigned for this. The moment you click on this mouse, corresponding the mouse, the operating system knows what is this number, what kind of interrupt generated based on this number. And corresponding to this number, whatever it is written here, that function will be called. Then you can say that by mouse movement, cursor is moving. By keyboard movement, text is typing. By some joystick movement, something is happening. Means for each kind of event it is performing at this stage, it generates an interrupt. Every interrupt will be identified by a number. Corresponding to this number, there is a function. And this mapping is stored inside a table called as an interrupt vector table. And once this operating system understands which interrupt occurred, he will search this table, that number. Corresponding to this number, he finds this function and he executes it. Now, what is the requirement here?
Sir, are the number already assigned to each?
Yes, already assigned,
like
already assigned, already assigned. Already it is assigned, and operating system knows this. Okay.
Function related to it, that is also assigned to it.
Yes, yes.
The function which is
Yes,
to be performed.
which function has to be run for this also, that is also already assigned. Okay. Then what happens now? When you, 1 minute, then relax. When the right function is called, and I told that it will not directly called, rather it will generate an interrupt. And when it is generating an interrupt, in this interrupt, it will pass a number 43. Why? Because for this write, already he knows that the 43 is the number, but he does not know how the write is written, nothing. He just know that I know that I have to call a write system call, and the write system calls number is 43, and 43 is received by whom? one software interrupt. And this interrupt has a different type. Which kind of type? Is it a mouse interrupt? No. Is it a keyboard interrupt? No. Is it a system call interrupt? Yes. Means inside your interrupt vector table, let's take there is a 11. 11 means it is a system call interrupt. System call interrupt. Then what will do? Since a trap has generated and the trap knows that I am generating because of one system call that is called, then the operating system knows that 11 kind of interrupt has generated. Then he immediately search in this interrupt vector table. What is the corresponding 11? A syscall. Then what it does? Now he tried to call this syscall function, and syscall is a normal function. Then what you link? Are you directly call this syscall? Not at all. What you did? You generate one interrupt. Pass this 43 to this interrupt. Operating system knows that one interrupt generated, and corresponding to this interrupt, he has called a function. Then can you guess what should be this function's work? This is called work. Guess please.
Sir, printing.
No, printing
That
is
is
okay.
right.
What he has to do? He has to call some kind of write function or not.
Yes, sir.
Yes or no? How will you know that, right? You can say, sir, syscall is a system call. It may be for write, it may be for read, it may be for many other functions present inside your program. But why it will call write? Why not read? How will you understand? Tell me
The
quick.
43 is passed.
Very nice point. Because he has passed this 43 number to him. When he received this 43, there is also one other table maintained. Inside this table, it is written, this 43 belongs to which system call? Write. This 41 belongs to which system call? Read. This 31 is pointing to which system call? Fork. So there are many system calls provided inside your operating system. Since you have passed this 43, I receive this 43 through interrupt. Once I know the interrupt, corresponding to the type of interrupt a interrupt service routine program has called, corresponding to this call, to this function, I have to call write because you have passed this 43 to him. Now the question comes, how will pass this 43? Again, there is a next question. How will pass this 43? Can your 43 will be passed? If 43 will be passed by him directly, then again he may be create a problem. Why will create a problem? मतलब आप बोलिए, आप जानते हो, you know that how to send XYZ message to P person. अगर आप जानते हो कैसे भेजना है, उसमें आप क्या करोगे? एक वायरस भेज दोगे. देन उसका तो करप्ट हो गया मशीन. क्या फायदा हुआ? इतना कुछ बनाया. I made a trap, I do these things, I do that thing, and again do like this. So that's why he will not directly pass this 43. Through some medium, it is going to pass this 43, not through this trap. अगर इसके थ्रू आ गया ना, आप जानते हो ना, कभी-कभी when two persons, those who are very मतलब directly not close to each other, they don't want to know about each other. Like one country talks with another country, they don't want to directly disclose everything. Then what to do? This person's detail may not be directly passed through this. So he has to be kept this 43 in some place. And this fellow will be receive these things from that place. And that place may be a common place for both of them. And usually this 43 will be kept inside a register. Yes, the register belongs to whom? The CPU. So he has just kept this 43 in the register and call this trap. Trap is generated. Trap calls the system call function. System call now check what is written inside this register 43. Then he search in this table. 43 का कौन सा system call है? Write है. Then write is called. And once the write is called, write knows how to interact with this hardware. So in this manner, the communication between this place to this place is happening. Little understood? Ask.
Sir, then also there is a flaw now because 43 is passed to register.
So, but this 43 is a number or function number or what, whether he has told, कुछ नहीं बोला, कुछ नहीं बोला. तो कुछ तो एक लिंक होगा. आप बोलोगे कि वो सुन लेगा लेकिन मैं नहीं बोला हूं, वो तो नहीं हो पाएगा ना. मैं बोला हूं, through some medium it has gone there, either secret होके गया है, encrypted होके गया है, कुछ होके गया है, लेकिन थोड़ा सिक्योरिटी तो चाहिए ना. आप ऐसे नहीं बोल दोगे कि डायरेक्टली भेज दो. हाँ, वही बस हो क्या है. ठीक है, समझ पाए अभी. So this is
that interrupt vector table is just to check trap.
Yes, very nice. This particular table is maintained for, vector table is maintained for checking which code, which number trap is mapped with which function, because function has to be ultimately run. Yes or no? And if you can look into it, sir, this system call is also a function, C function. This printf is also a C function. Just to call a write, I do these things. And for the what purpose? He don't want, means your manager does not want any outside fellow cannot directly enter to my kitchen. They have to give me something, and how I am telling to my cook, the customer doesn't know. वो बस बोल दिया है. कभी कभी होता है ना, कुछ पैटेंट वाला होटल होते हैं, वो लोग बताते नहीं कि कैसे पिज्जा बनाएंगे, एक्स टाइप का पिज्जा कैसे बनाएंगे वो बताते नहीं है. Like this. Yes, it is happening in this manner. Yes, please.
Sir, that trap and interrupt are the same word.
The trap and interrupt का difference बोला. जब भी कहीं पर बुक में लिखा गया trap, आप सोचोगे कि एक सॉफ्टवेयर इंटरप्ट जनरेट है. If it is written as a normal interrupt, एक हार्डवेयर इंटरप्ट. ठीक है ना?
Okay,
Okay,
sir.
yes, I'll visualize these things by a small operating system. As I told, my goal should be for this class is you can visualize the way we are discussing, the same way it is happening. Otherwise, no meaning. Yes, that's why I collect today before class. I just collect everything so that you can know how exactly this printf works. Okay, now look into it carefully. Huh? So this is my API. Agreed? Yes, this is my API, and
Yes, sir.
we are calling inside a.c program, and you are writing main, and inside the main you are calling printf. Yes, or you are writing something like a %s and some p. Printf. ऐसे लिखते हैं नहीं? Yes. Then this function is called, but the definition of function is this. Where it is available in user mode. Please remember, it is available in. And what is written? If you can see carefully, I've just removed few codes. You can carefully see. He first check %, then checks what? S is written or C is written or D is written or what? If it is a S, then it is going to print what? A string. What is a string? Collection of characters. Then do you think it is nothing but a printing multiple characters means display the character inside a loop or not? Am I correct or not?
Yes,
If
sir.
you are writing %C, only once. If you are writing %S, same style code, but with a loop. That's why you can find for this S type, he is using a loop. But for the C type, he is using only one space, put C. Okay, distinguish. Now come to this.
It is using that parameter to identify whether it is
Yes,
string or
whether it is a format specifier for string or character or what. There are many format specifier in C now. So depending upon this, I have removed for D, F, I have removed it because it is not unnecessary to show it here. Okay. So once it is done, but both the functions are using which function? Puts. Okay. The puts' work is to take the data which is pointed by this pointer and write into some file. What is the file here? This file is my monitor. Why? In Unix operating system, every hardware will be represented internally as a file. And this file is pointed by whom? FD. आप C में पढ़े होंगे, एक फाइल डिस्क्रिप्टर बनाते हैं जो कि फाइल डिस्क्रिप्टर एक फाइल को पॉइंट आउट करता है कि नहीं? And he wants to write this text P में जो डाटा है उस डाटा को इस फाइल को राइट करने के लिए he wants now. And how it does? Still it is a function. This function is what? Still it is my API. Putc is API. Then what this putc has to? Putc has to be user write. The write is a system call which is known to the operating system. Then putc calls this write function. Don't think that I have written. This is the exact code written inside the operating system. Okay, that's why you have to believe. It is only simply call this write. The moment you call this write, now somehow our user and kernel mode distinguishing starts. Because I cannot directly call this write. If I call this write, means I can also call write directly here. It is just like a function call, but I am not making a function call. Rather, here I am going to make a system call. Okay, and how this making a system call? The moment you write, he is executing a low-level program that is called as assembly language program. And what he does, he take this name, right? Yes, and store the number corresponding to the right, whatever, जो 43 होगा ना, वो 43 को लेके कहाँ रख रहा है? एक register. So this is your register. रख दिया? रख के क्या किया? Immediately generate one interrupt. This is interrupt. INT means interrupt. Okay.
Did it generate many interrupts or one interrupt?
One interrupt. No, because एक ही चाहिए ना आपको सिस्टम कॉल करना है, इसलिए एक इंटरप्ट जनरेट कर दिया. ए इंटरप्ट को हम क्या बोलते हैं? ट्रप. ठीक है ना? बिकॉज सॉफ्टवेयर इंटरप्ट क्या? The moment it will be call an interrupt, what the interrupt has to be do? Tell me. We discuss. It has to be search in where?
That vector.
Vector table. Vector table. So इस सर्च में ये यहाँ पर देखिए सर्च किया. Yes. अभी at this moment from here to here a mode gets changed. Means now you can say it is a user mode and this is your kernel. Okay, यहाँ पर change हो गया. Once it is changed, then what he does? He told that corresponding to this TC's call is one kind of a trap. For this TC's call, what to do? I have to call a function. Which call? syscall is a function. बोला था कि नहीं? वो एक फंक्शन कॉल करेगा. उस फंक्शन के अंदर क्या काम होना चाहिए? बोलिए.
43 का corresponding check.
Very nice. 43 अभी किसके पास है?
Register.
रजिस्टर के पास है. अभी चलते हैं 43 को syscall को फंक्शन. Because now you are enter into the operating system. Here you are now in the operating system. Now once you enter into the operating system, देखिए वो बोला ये जो था ना TF कहाँ पर था? Trap. From this TF he has got this EX value. समझ पाए? And कहाँ पे रखा? नंबर पे. And नंबर पे अभी कहाँ रहा? क्या रहा? 43. And what this operating system maintain? The operating system maintains one array of functions. This is called as a array of functions. And what is wrote? ये जो number था ना, corresponding to the number एक एक function लिखा गया है. सोच लीजिए. तो right का कहाँ पर है? हमारा यहाँ पर है. समझ पाए? यहाँ पर है. तो ये क्या किया? देखिए. Whatever the number he has taken now, then he call this array, syscalls array, syscalls. This is syscall function. This is syscalls array. In this syscall function array, he has passed this num and call this function. And which function will be automatically called? Syswrite out. Yes. This.
X क्या है?
Yes. ये X एक register है. ये X register. इसका register का नाम है. Okay. अब पढ़ोगे कोआ में पढ़ोगे एक accumulator register बोलते हैं उसको. You will study in the कोआ. Here सब कुछ discuss करेंगे तो खत्म नहीं होगा course. इसलिए it is a register where he has kept. I told. Then he has received this, and once the function gets called, then my syswrite function called from here, because it is mapping with whom? This one, and this one is called from. And here actually it should be written how to write into monitor. समझ पाए?
Sir,
हाँ,
sir, but it will require that character array which we have to print it na.
हाँ, वो वाला यहाँ पर दिखा है नहीं. वो क्या करेगा, जो parameters है, that parameter will be stored in another registers because there are multiple registers present. एक रजिस्टर में नंबर लाया और एक रजिस्टर में और कुछ रखा डाटा को, then that data will bring and सही पढ़ना. Okay, so this is the overall figure of the system. समझ पाए पूरा? ये पूरा का पूरा कोड ऐसे ही मैं दूंगा एक असाइनमेंट करने के लिए आफ्टर नेक्स्ट वीक. यस, पूरा देखोगे कि ऐसे ऐसे स्टेप्स हुआ है. यस, ask then I'll go to immediately next topic. Quick.
Sir, in that printf function, so there it is in the definition in the parameter int fd. What is that?
I told no, he is writing these characters into a file. What is my file? The file is my monitor. I told that in Linux operating system, every hardware also considered as a file. मतलब वो अगर मॉनिटर को राइट करना चाहता है, if he is writing to the file, means indirectly it is writing to the monitor.
Sir, but it is an integer na.
No, that's why no. आप फाइल प्रोग्राम लिखे हो, फाइल प्रोग्राम f ओपन करके लिखे हो, a.c को कैसे राइट करते हैं वो चाहिए, सब कुछ पढ़ के आइए. सी प्रोग्राम ऐसे लिखते हैं कि नहीं, a.c करके w मोड में लिखते हैं, फिर यहाँ पर देते हैं कि f ओपन, सॉरी फाइल
pointer fd.
and this fd is this. Got it? And this a.c is my monitor. Understood? Yes.
Okay.
So this is called as your system call. Yes. Now I'll go back to just a minute. Just 1 minute. Fine. Then we'll go back to our place. Now you know how the system call works. So once the system call works, I reach at which level? Now I am reaching at the third level. What is my third level? यहाँ से आया, देखिए यूजर से आया, फिर से यहाँ तक आ गया API, फिर API से मैं आ गया OS को, फिर OS से बोल रहा हूँ I want to connect with my hardware. Yes. Now the question comes, how this one also connected, because it is also software. Then how this hardware will be connected? This software is connected with the hardware with the support of basically two things. One thing is my device driver. Another thing with the help of a device controller. Yes, वो क्या है? थोड़ा आप कंप्यूटर तो देखे हो, कंप्यूटर के बारे में जब भी आप देखोगे, एक सपोज USB पोर्ट आप कनेक्ट करते हो कंप्यूटर में, corresponding to this USB port, inside this one chip and some small chip will be there or not? अंदर एक होता है कि नहीं? Yes? वो आपका डिवाइस कंट्रोलर है. मतलब ये अगर सोचोगे ये आपका प्रिंटर है. If this is my printer, wherever this wire and gets connected, एक wire आके कनेक्ट हुआ होगा, यहाँ पर देखोगे एक कुछ कंट्रोलर होगा. Yes, the device controller. यहाँ पर हो सकता है, या आपका मॉनिटर में आप कैसे सोचोगे? ए मॉनिटर में सोच लीजिए, कहां पर सोचोगे? ए है, ए आपका है प्रिंटर एंड ए वायर कनेक्ट हुआ है आपका सीपीयू को, मतलब सीपीयू मतलब ये आपका कंप्यूटर है. सोच लीजिए जहां पर ये कनेक्ट हुआ है पोर्ट, यहाँ पर देखोगे एक कार्ड जैसा होगा. एंड दिस इज माय कंट्रोलर. एंड व्हाट दिस कंट्रोलर बेसिकली कीप्स? This controller keeps also a small CPU, some registers. All these things are present. Why? Because he knows how to handle with this hardware. Because the CPU does not know, the original CPU does not know the whole thing about this. But the person who has made this hardware, he may know about everything about the hardware. So that's why there may be some intelligent CPUs and registers are present with this device controller. एक टॉपिक पूरा हम पढ़ेंगे, मैं बस ओवरऑल बता रहा हूँ. Suppose now a device controller is ready with this hardware, but can your OS is capable to connect with any kind of hardware, or he can't? सपोज मेरा हार्डवेयर के पास एक कंट्रोलर भी है and through the controller I can send the data and do it, but OS is a software. Can this OS knows about your hardware controller properly or not?
No,
Not
sir.
necessary.
No, sir. No, sir.
Not necessary. कैसे सोचोगे आप एनालाइज करोगे? कभी कभी जानते हो एक नया यूएसबी ड्राइव आप खरीद के लाए हो, when you enter into your computer वो देखता है, बोलता है कि not detected, install new driver.
Yes,
बोलता है कि नहीं?
Compatibility.
Yes. Compatibility issue क्या है? Because this driver is a software, this controller is a hardware. This driver who has made, कहां से डाउनलोड करते हो? जिस कंपनी का हार्डवेयर यूज करते हो, है कि नहीं?
Yes,
If you
sir.
are using X
Yes, sir.
company's hardware, this X company provided a software called as a driver, because X company knows that if my hardware is connected with 3 pins or 4 pins, whether my first pin is used for the reading or writing, who knows? The person who has made this hardware or not. Do you think that in every hardware the first pin should be meant for read? May not be. The first pin may be used for sending command, the second pin may be read, third pin may be write. In another hardware, the first pin may be a read, second pin may be a control message sending, and fourth pin may be a write. Since my hardware's design gets changed, the person who has made this hardware, he knows about all the details. Since he knows, he has to be provided a software, and that software, once you connect it here, install inside your operating system, then when the operating system interact with this controller, he has to be interacted through this device driver. Correct or not?
Yes,
समझ
sir.
में आया है कि नहीं? ये चाहिए कि नहीं? एक डिवाइस ड्राइवर इसलिए. Once the device driver will be known, then OS is capable to contact with your hardware in a nice manner. So this is the overall layer diagram of this. The user interact API through a programming interface. And this API is connecting to the OS through the system calls. And this OS is connected with the hardware with the help of the device driver. And up to this, all looks like software. But
how OS
these things
is connected
is
to device driver?
and OS, because आप जब OS में इंस्टॉल कर देते हो, OS को पता है कि इस डिवाइस के लिए कौन सा फंक्शन रन करना है, and that function will be provided by whom? This device driver. Because device driver is a program, and that program means it is a collection of function. He knows how to write. Suppose OS को write करना है मॉनिटर को, मॉनिटर का एक डिवाइस ड्राइवर यहाँ पे फिर से प्रीवियसली इंस्टॉल और नॉट इंस्टॉल हुआ होगा कि नहीं?
Yes, sir.
हुआ होगा. So OS what will do? The OS, when will call this write, no, syscall write. This syscall write actually indirectly call this driver's function. अगर driver function को call कर दिया, he has sent the data to the driver function, and this driver function will be sent it to the hardware. So there is no direct involvement of OS with the hardware also. Because वो क्यों इतना रिस्क लेगा कि क्या 1000 आइटम बनाएंगे तो OS क्या 1000 आइटम आपको लिए पहले से जान लेगा? नहीं ना.
Sir, but many times when we install that kernel or that operating system, there are some default ones.
हाँ, वो
that-
क्या होता है? वो क्या होता है कि well-known drivers are already installed,
Okay,
coming along with your OS. That's why no need to install. Okay,
sir.
समझ पाए? Then
Yes.
we studied what is this layer structure. ये बोलते हैं आपका layer structure of OS. थोड़ा बुक में आपको अच्छा डायग्राम मिलेगा, बट कॉन्सेप्ट आप समझ लियो तो डायग्राम ऐसे ही ड्रा कर लोगे, काम खत्म. ओके, layer structure operating system. But what you have not studied, we have not studied that I told the definition of operating system 2 things. One thing I told, one is make an interface between these two with the help of this. Another one is the reducing complexity. But यहाँ पर तो कभी भी सोचे नहीं, पढ़े भी नहीं. How is it reducing the complexity? Means if it's reducing the complexity means how he has to manage the resources. How OS manages the resources. What are the basic resources? Then we'll see what are they managed. The basic resources I can say is a CPU, the memory, or indirectly here we can involve as a processes. Yes, process. Because CPU तो पूरा hardware हो गया, वो तो मजा नहीं आएगा. Processes. Processes क्या है? Thousands of processes currently running inside my system, but I have not that much resources. Because I suppose 10 processes are currently running, and all the processes needs a printer. Can you provide 10 printers? No. You will provide only one printer. But my operating system manages this printer in such a manner that we never feel that I have one printer. I have 10 printers. We feel because ऐसे वो arrange करता है कि sequentially who will get the CPU printer next. Then we don't have to think it. So that's why it is a process has to be managed. Another one is memory. Another most important thing is the file, because without a file, neither I can store something nor I can read something. So there is a file. And last one is becoming a IO. What is this IO here? The IO means every IO devices, hardware devices. Now, hardware devices, how it is going to be managed by the CPU. And most important, which we never consider, is the protection. What is the protection? हम थोड़ा C में सीखते हैं. If you can relate. If you declare a 5 size integer, int A5, can you able to store here 5, 9, 10, 12, 15,
Buffer overload.
17, 18?
Buffer overflow.
Yes. In this case, sometimes he is giving you, sometimes he is not giving you. Why? This memory? Because if no space is continuously present, then he cannot give you to store 7 elements because you have told 5 elements. Means he is giving a protection of the memory which is available to you. One kind of protection. Another kind of protection. Suppose I have 2 users are present in this computer, X user, Y user. Whatever the X has created the files, can a U user directly see these files unless until X gives the permission? No. Means who is managing? The operating system has to take care of this, how one user's resources should not be directly accessed without a permission by another user. So that also has to be managed. So this is basically the managing the resources through which he is reducing the complexity. Okay, next class पढ़ेंगे, कल का class और थोड़ा detail. Okay, is it understood little bit?
Yes, sir.
Okay.
Yes, sir.
So I'm ending. I have one more class now. One.
Thank you, sir.
Thank
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
you.
Yes, sir.